Polygons are those classic shapes that we've talked about since kindergarten, but we want to move past just identifying them and try to analyze them. In this lesson, we'll do that by finding the perimeter and area of these polygons as they lie in the coordinate plane. Let's define a few terms first. So a polygon is a closed plane figure formed by 3 or more line segments, or what we commonly call sides. So a polygon is a closed plane figure formed by 3 or more sides. Each side intersects exactly 2 sides, one at each vertex. And that's so that no 2 sides with a common vertex are collinear. You won't see them all on the same line. Okay? So again, a polygon is a closed plane figure formed by 3 or more sides, and each side intersects exactly 2 sides, one at each vertex, so that no 2 sides with a common vertex are collinear. Let's look at an image of this to make sure we understand what it is we're talking about. So look at this polygon over here. So here we see the closed sides, right? All the closed sides, at least three sides, and each side is intersecting at a vertex. So like right here. That's a vertex, right there. And we see that no 2 sides with a common vertex, like these 2 sides, are collinear. They're not going to be collinear, right? They're not forming that straight line. They're all not on the same line. Okay? So vertex here, the sides are here, and then we name it using the vertices, okay? Using all the vertices in order. So A, B, C, D, E. Okay? So we would name that polygon A, B, C, D, E using all the vertices. So if you look at these tables here, we can kind of get an idea of how the name of the polygon is related to the sides. The number of sides determine that name of the polygon. And some of them you're familiar with, some of them you may not have heard about. So let's talk about them real briefly. So a triangle, tri, we know is commonly stands for 3, or indicates 3. And so a polygon that's a triangle has 3 sides. A quadrilateral, that quad term, is actually for 4. So a quadrilateral has 4 sides. A pentagon has 5, penta. A hexagon has 6, hex. And a heptagon has 7. So again, the number of sides is determining the name. An octagon has 8, a nonagon has 9, a decagon has 10. If you think like a decade, decagon. And a dodecagon has 12. Okay? And then if you're talking about, since the sides determines the name, we would say that any polygon with n sides, n representing any number, it could be anything. That's just an n-gon. That's not a term we normally use. That's just saying that whatever the number of sides is determining what the name is. That's all that expression is really representing. Before we go on, let's discuss a couple more terms: convex and concave. These are easily confused, so let's put some images to it. In physics, they have a simple application in terms of mirrors and how images are reflected. Convex mirrors curve outwards. Think of mirrors that you might see in a hospital or a large building where they place them at the corners so you can see around and see what's on the other side. That's convex, that eye shape or glass shape that curves outward type mirror, that's convex. Concave mirrors are curved inwards. Think of like a cave being inwards. These type of mirrors might be found at headlights or astronomical telescopes because they help with reflecting incoming light to a certain point. In geometry, we also use convex and concave to describe polygons. A polygon is convex when no line that contains a side of the polygon contains a point in the interior. Let me clean that up for you a little bit. Interior. Did I spell it wrong again? Oh my goodness. Interior of the polygon. So a polygon is convex when no line that contains a side of the polygon contains a point in the interior of the polygon. Okay? So if you look here at this convex polygon right here, so each of the four sides, if we look at the line that contains each of those four sides, here, here, and here, right? And as they extend out, okay, they don't have any points in the interior, okay, in the interior of the figure. Okay, so that would be a convex polygon. A concave polygon would just be the opposite. Okay, so any polygon that is not convex is concave. Any polygon that is not convex is concave. So if we look at this concave polygon here, okay, it's got these sides, and some of the sides, right, if look at the lines that contain them, they're not going to have points on the interior, but this segment right here, and this one too, if we look at the lines that contain them, they would pass through the interior right here of the polygon. And so that's concave, okay, because there are points on the line that would be in the interior of the polygon. So we call that concave. If we look at an example of identifying a type of polygon, if you look at that first example there, so we have this polygon here, it kind of looks like a Pac-Man that's laying down. So if we classify that polygon by its number of sides, we would count how many sides it has. 1, 2, 3, 4, 5, 6, 7, 8. There are 8 sides, and so that'll determine its name. So it's an octagon. Obviously, that's not the normal type of octagon we're used to looking at. We're used to thinking of like a stop sign, but that is an octagon because it has 8 sides. But it's not a normal type of octagon we're used to looking at because it is actually concave, right? So if we look at the segments, right, and we look at the line that contains them, these two sides, these two sides would be contained in a line that would pass through the interior, that would have points on the interior of that polygon. So we would say that this is concave. It's an octagon and it's concave.